Hello everyone. Are you able to hear me clearly? Great, great. So how are the assignments coming up? Great, 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 great. So in this session, almost everybody is actually performing pretty good, and I'm pretty happy about it. And so let's start then. Okay. So before starting, do you have any question? Okay. So I'm assuming that there are no questions before starting. Good. I'm going to anyway repeat that last example of Java. Thank you, Huda. I'm assuming you Huda. And yeah, okay, right, right. All right. So let me just. So the example was clear to everyone, right? So first you install Eclipse, and since you install Eclipse, then create a Java project, add these libraries, and this project is also available in the exercise session number 4. There is a zip file available there, so you can download that, and all the libraries would be available in that itself. Okay. And the libraries are for Hadoop 2.0, 2.x, so you can say. Also, now there is a minor change because Java 6 has been obsoleted by most of the OSs. So we are moving to Java 1.7, yeah, JDK 7. But that's okay. We can still have the Java compiler setting to the lowest possible, which is 1.6. Okay, so that it runs everywhere, um, irrespective of how old is the system. Now, this is how you create your mapper. So for creating a mapper, you generally extend a class called mapper. You create, this is your name, whatever you want to put here, you can put the class name. So this is a class, this is a stub mapper class, which is basically an extension of the base class called mapper. And while defining what kind of extension you are providing, how are you extending mapper class, or how are you inheriting mapper class, you define that these four data types are, two data types belong to the input data, and two data types are output to data. Yes, base class is inbuilt. That's correct, Nitika. So mapper is part of the library which we have added, and here this method is something which you need to write, and the syntax of this has to be, the data types of key value pair has to be same as what you have defined. You have defined input key as object, i- input value as text, right? So when you are extending, so whenever in case of Java, whenever you are extending a base class, if that base class supports, then you can extend and concretize it. You can say that I am an instance, this particular class is an instance of the base class, but in a concrete sense. In this class, only this particular data type can be stored. Okay, so that's how you can you define things. in Java. So for example, let's imagine that, okay, so this concept is little difficult for some people who have not read the templates. So imagine there was an array list class. Okay, it's an abstract class provided to you by Java. Now you want to create an array list in which array list is what? Where you, so array list has methods like add, remove, and mm, so let's just imagine that these are the two methods provided by this class called array list. Now imagine that in array list you can add any kind of object. Okay, in array list you can add any kind of object, but imagine that you want a special kind of array list, saying that I want an array list in which only customer object can be stored. So you say customer array list, customer list extends, you say public class customer list extends array list, and then you say customer here, whatever object you want to say, and then if you do that, then by default your customer list say cl equals new customer list. Now on in cl you can only add customer object. Okay, this is a customer object I have created here itself, new customer. Okay, but this is correct. Okay, this is correct, but in case you try to add something else, say you want to add new float, okay, or new person, this is incorrect. This is incorrect. All right, so this is the meaning of extending with defining a data type. All right, similarly here when we say our step mapper is extending mapper and is defining these methods, these data types, that means in the map method you can only have the data type, the key as object and the value as text, same as what you have defined. Okay, otherwise it will give you an error saying invalid function. Similarly, this is the output key and this is the output value. Okay, here we are defining more than one type while extending a base class. All right, so while writing to the output you can only put text and long writable into the output, otherwise it will give an error. So this is a way of concretizing things. Okay, so there is no scope of a error anywhere. So in here is your logic, and this logic says that the as I told you, in the normal functioning of Java MapReduce, the key you get is the byte count. Instead of a line number, you get the ith byte, and value is the line, the full line, and therefore you can basically write things like this. You can do anything inside this function as long as you are writing into context.write. And this code is also valid. You are free to not write anything into context. That means there'll be no key values going out. So yes, Vikash, we are talking about byte offset as object in Java. Yeah, that's correct. Yeah. So you can cast it into a number, integer. All right. You can cast it into integer. It's basically an integer. I did not get Nitika. What's your question? No. So you can write something like my object, okay, and then here you'll have to say my object, my object. So this object is provided by Hadoop to you. so that you can write, you can give out the data into this object. You're writing into this object. Okay, but the data type has to be context. This is something not configurable on your label. All right. So here all we are doing is taking the value, is splitting it by space or tab, putting it into words, and then iterating over words and writing into the context. All right. Now, in the reducer, you can see that similar way we have extended. We are saying our input is text and long writable. Our output is text and long writable. And again, in the same fashion, this is the input you have got, and we can write our output into context. Okay, so we can write whatever we want to write, and that's it. All right. So this way we are able to create a reducer. All we are doing is iterating over the values and then summing it up. Okay. And notice that this long writable and this long writable have to be same data type. This and this have to be same data type. Also, whatever data type is given out by mapper, this data type for the input to the reducer will be the same. Text long writable, text long writable. Why? Because the output of mapper goes into reducer. Just that values are grouped together. That is why you see an array list. Make sense? So again, now this is how you stitch the classes together. You create an instance of job, and then you set mapper, set reducer, set output key class, set output value class, and so on. Okay, even if you do not you know uh, even if you do not define other variable, it will work. Okay, and the actual execution starts at this point when you say job dot wait for completion equals to true. This is where the execution starts, and it waits for MapReduce to complete. And once MapReduce has completed, system.exit will return the value. All right, moving on. So let me just show you the code. Let me close this one, close all. So this is one class, the simplest one, which is available in the example given in the session 4. Here all you need to do is, last time the mistake we were making there was we did not have any package. All right, now we have defined a package because I think it demands a package somewhere. So here all we did was we said file, export, then jar file, then we said this is our, you see everything is selected here, and we have provided the name for the output. We call it my mapr.jar, and then we say next, again next. Here we leave it everything, and here we are saying that our entry class is stub mapper, stub driver. Okay, that's our entry class. All right, and then we say finish. The file already exists, I want to overwrite it. All right, now it is written to the disk, and let's copy it. So I'm saying scp, those who are on Windows, they can use WinSCP. I'm using SCP. Those who are on Mac or Linux, they can simply use SCP. SCP is by default installed, just the way SSH is installed on Linux and Mac. On Windows, you have to install with SCP. So here I'm saying SCP, this folder name, and then student, and that's all. Okay. So from source to destination, I'm copying it. So it has copied it there. Now let's go to, I have already SSH'd it. This is my Hadoop 1 session. Okay. Now let's execute it here. I say, is the font visible to all of you, or should I increase it a little bit? All right. Now on the second terminal, we are already on Hadoop, and let's execute. So let's go to my folder. I'm okay. So my folder was sgiri. Here there will be one file. If you say ls minus lrt and more, uh, I will, okay, yeah, the last one you see. The last one is the one which I've just uploaded. I'll say Hadoop jar, and this is my jar file, and I press enter. Now that means our jar is running, our step driver is running. This is the error message that is coming from our file. This is, you see, it says that if argument not length is not equal to true, 2, then print this message. Okay, so that's what is being printed. Let's put two arguments. So my file in HDFS, so to a Hadoop program, you have to provide the data from HDFS. Okay, let me see, there's some question. All right, there's no question. So here we say Asgiri slash Asgiri is also a folder in the HDFS as well as here on local. Ideally, I should have created a different name to avoid the confusion. All right, so I say Asgiri slash word count. There is this folder I've already created containing the data of word count, and I put it here Hadoop jar and this, and press enter. Now it says provide the output directory. Let me provide the output directory. Word count slash output. Now what does it say? It says a directory already exists. Okay, let's call it 18 April. So whatever is the work, it will finish and put it in that folder. This folder, as this is also going to be in HDFS. All right. Now here we have not provided the driver. Please notice that we have not provided the driver. Reason being, we have already, while creating the jar, we had already mentioned it in the jar itself. Okay, so we had already, if you see here we had provided our entry point. If you do not provide an entry point here, then the first argument to your program, to Hadoop jar, will be after the jar file. The first argument will be the entry point. Okay, so now it has finished the work, and in the meantime you could have checked, we could have actually checked what exactly is going on by looking at this folder, this URL. Okay, also those who are curious about uh, debugging a Java code, they should take a note that whatever you do here, say in your Java code, you are doing system.out here and there. Okay, imagine that inside your mapper, you are printing something. You are saying system.error, or system.error, or system.out. Okay, so okay, I some error, something you're printing. So you can debug your mapper and reducer by printing to sysout. Sysout will not get mixed up with the output you are giving to reducer. Okay, it will not get mixed up with that. All right. Now, if you look at it closely, here, let's go back a bit. Your In the logs, you will see sysout and std out and std error messages separately. Okay. You will see the std out and std error messages separately. What is the Hi, is the voice now okay? All right. I was just trying to figure out. Yeah. So Nitika's question is, what's the use of package here? So generally, you are saying that your file exists in a folder called my. In a larger project, you cannot put everything into a single folder. Ideally, you organize your code and your classes in a manner that classes which belong together should be in one folder, and so on. So whatever folder you put your classes into, you mention that package name. Okay. Yeah. So it's a good practice to have a package name in place. All right. It's a good practice to have package name in place. If you do not put here, because if you do not put a package name, the classes will be just spread around. Therefore, it's a good practice, and probably the last time the error was occurring because of this, or maybe because of the way we were creating jar. Most likely it was because of not having a package. Okay. So it's a good practice, though I am yet to figure out why is it mandatory in case of MapReduce to have packages. All right. The only difference between last time and now is that I have mentioned the package name. That's all. All right. Also, pay a close attention to all these numbers. Okay. So here, number of bytes read, number of bytes written from the file, number of total read operations, number of large read operations. All of these things make a lot of difference when you do it on when you are trying to optimize your MapReduce task. Okay. Okay. Here, in case your time spent by all reduced task is too huge here, okay, is very huge, imagine this, then what will you do is you should increase number of reduces. If you increase number of reduces, time spent by reduced task will become lesser, but the total IOs, if you go down a little bit, so okay, there is okay. Yeah, this shows you how much memory you used at times, and There was one network IO. I'm yet to see that network IO. Okay. All right. Never mind. I think when we are running it. So yeah, this one will be okay. So if you have increased the reduce time reducers, the chances are after a point of time the total time taken by your map reduce might increase. Okay, it might increase. So keep that into picture. And in case your network time is going up, when you are increasing number of reducers, you should immediately stop. In case the total time taken by network plus reducer and mapper, the overall time taken is increasing because you are increasing number of reducers, you should immediately stop I- increasing the immediately stop increasing the number of reducers. All right, because if you increase the number of reducers, although the time taken by reducers will become low, but lot of time will be spent in shuffling the data across the cluster. All right, as we talked earlier, you should always have a test case. So good news is, if you see here, a slightest change I make, I will have to create jar and then upload to the server, right? Instead of that, if I'm just testing my logic, I can write a test case. I can write a test case like this and then test it immediately. Okay. So this Hadoop provides this something called MR unit. Okay. If you can see, the MR unit classes are there. So map driver can execute by itself. Map driver can execute by itself, while reduce driver will not will can execute reducer separately, while map reduce driver can execute map and reduce without need to execute on the Hadoop cluster. Okay. Vikas's question is it necessary to be for jar to be in HDFS? No, jar has to be on the local file system. Okay. So you can see this in the test cases, although I have written a very rudimentary test case here. I've created something called a MapReduce driver, and I'm adding some sample input here. Okay, I'm saying this is my input, this is my input, and then run the driver. And on driver, I've told that this is my mapper and this is my reducer. Okay, you see, when I'm setting up to map reducer, I'm telling that this is my mapper and this is my reducer. What is my mapper? My mapper is the stub mapper, and reducer is the stub reducer. Okay, so for this fake Hadoop, you can think of MapReduce driver as a fake Hadoop who executes mapper and reducer on your local machine. It tries to emulate, it tries to fake the behavior of Hadoop for you. It'll take your mapper and reducer, run them, and then give the output of one to another. Okay, so here what exactly am I doing? I'm running the map reduce driver. What does it mean by running? It will internally run mapper and reducer on top of these lines which I have provided. Okay, and once I have done that, it will give me the output in the form of word and its count. Okay, then I can print it Or maybe, I can do things like, output dot keys, output dot get, or output dot where is, okay, output dot size, and uh, I can say assert equals. So what will be the output size? It will be total number of element in this list. And how many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there are total 11 words. So let's see if that is true. Okay, A has to be, okay. So we can say run and then say here, where is the run as JUnit test case. So you can see that here I have written fail, which means it will always fail. Generally, the way you build your Java code or any programming language, you always say, you know, before even starting to code, you start writing the test cases. Let all test cases failed by default, and you keep on fixing these test cases. Okay, that is the reason I have put fail, fail, fail everywhere. It's a reminder to me that these test cases need to be written. So here it has run successfully, and it has basically, this test case has passed. Okay. If we add one more word here, it will give an error because total number of words, it says it was expected 12 but is 11. Okay. And it has to be something, generally you write it this way. Okay. Now, although it does not make much of a difference, it's just for syntactical reasons. So you can see this. It says expected 11, but there were total number of 12 things because we have added one more here. All right. So this way you can actually test everything correctly. And these are the error messages we are printing everywhere. All right. So is everyone with me? So the idea with the test cases is that with respect to each and every function or every functionality, you write some another Java code to test the actual piece of code. Now, you cannot go wrong at both the places. If you go wrong at either of the places, either in the test case or in the actual code, it the test case will fail. Okay. Therefore, having test cases not only in case of Java, but in other languages also, having test cases or test driven development, we call it TDD, is a very important task. The other criteria is generally the code coverage. That's a different story altogether. All right. So whenever you are writing test cases, you have to cover as much piece of code as possible. If your test cases are not covering the whole code, the whole branches of the code, that means you have not tested your code properly. And for that, there are code coverage tools, and those code coverage tools actually do a pretty good job in identifying. That's correct, Huda. So you will always have to have maybe a Hadoop driver class, a mapper class, and a reducer class. Although you can create a single class having these classes as internal. Okay. Tarak's point is that can these test-driven development told in general rather than only in Java, or is it mandatory to know Java thoroughly before these classes? Some concepts are going right above the mind. I agree with that. So, see, whenever we talk about the test-driven development philosophy, the philosophy is before you start writing code, you create your test cases. And what does it mean by test case? For each functionality in the code, you write down a function that the name of that function should start with test. Okay, we write down a function with that the name should start with test, and then run that class. Okay, and how does it test? In your test case, inside the test case, you write assert true or assert fail. Okay, assert true or fail or things like that. You keep on checking and comparing, and based on that, it whenever the test cases are run, when running test cases means picking up all your functions whose name starts with test and run them one by one on the input data, and then running the assert true or assert equals or assert false, those kind of functions, and ensuring that those functions should be evaluated correctly. That that is the meaning of text driven development. So all the time what you do is, before you start writing code, you basically write down all the test cases, and as and when you are writing code, your test case will start succeeding one by one. Correct. Thank you, Vinay. Test-driven development has nothing to do with Hadoop. It is just a programming paradigm to ensure that all the cases you wanted to cover are done correctly. Thank you. So you can actually have a look at the other courses where people have done test-driven development. Okay, but it's a good idea to know test-driven development. All right. So we have created test cases. This is so the important part which I wanted to show you was the MR unit case, where you can create the you can fake the Hadoop part. So this is the Hadoop emulator kind of classes. They run locally, the MR unit classes. They take the mapper and run that and give the results. All right. Okay. So now the things which we left last time was, so should we move on? Everybody's clear with respect to Java here? Good, good. All right. So the complex problem which we talked earlier a bit was that the input given by Hadoop to our mapper is in the form of line by line right now, correct? But when we talked about HDFS, we always talked that our files are broken, files are cut exactly at 128 MB. Now, what if half of the line, that 128th MB's marker is in the middle of line, correct? Because 128th MB not necessarily has to be on the line ending, right? And HDFS doesn't care about your logic. So, so that's what is being displayed in the diagram also. You have the block boundary on the below, meaning 0, 128 MB, uh, then 256 MB, and so on, correct? But your line number, if you see the fifth line, fifth line is half on the one block and rest is in another block. Similarly, the ninth line, half of it is on one block and half of it is in the next block. So what do you do in such cases? How does Hadoop handle it? Okay. So basically, so this problem is statement is clear to you, right? So we always talked about mapper will get one line at a time or one record at a time from the input and so on. But blocks are not line wise, they are byte wise. Okay. Line is more of a logical representation of the data. So how does Hadoop handle this, and how does Hadoop make sure that your mapper gets full line at a time? Okay, now this again, this example is different from the diagram. So you imagine that you have line 1 50 MB, line 2 50 MB, line 3 50 MB. Okay, so the block 1, so if you have 150 MB file, block 1, there will be two blocks. Block 1 will contain line 1, line 2, and some part of the line 3. Rest of the part will go to the second block. Okay, now the way Hadoop does it is by creating a logical representation of the data called input split. Okay, and what is input split? Hadoop divides input into pieces called splits. So on top of the blocks, when you start your Hadoop job, when you say Hadoop jar your code, at that moment of time, input splits are created on top of the blocks. That is the logical representation of the data. These input splits are of various kinds. There are many kinds, and in case you demand your own, then you can basically create your own input split. All right. So other than block, a input split is something which is more relevant when we talk about Hadoop MapReduce. Each input split contains many records. I'll talk about it more. So just give me a second. So effectively, the whole file will be broken down, or the whole file will be represented as bunch of input splits. Okay, whole file will be represented to you as bunch of input splits. Each input splits will further be uh, splitted into records. And what is a record? In our case, when were doing line by line word counting, each line was a record. Each line was a record, and each input split was bunch of lines. Okay. Now map runs on each record of split. The map function which we showed you, this map function, this let me show you this. This map function will be executed on each record at a time. But the instance of this class meaning the creation of the object of this class will be only done once per input split. If you have got two input splits on one machine, then there will be two instances of the mapper. But for each line, we are not creating one instance of this class. We are just running the function for each line or each record. Okay. So map runs on each record of this split. If you have too many input split, so input split is something which you can customize. Okay, when we will show you how can you customize an input split. Already, although there are multiple kinds of input splits already, but in some circumstances, you might want to customize the input split. But just keep in mind, if you create too small input split as compared to the block size, then there will be too many input splits, and hence the overhead will be too high. Meaning, so we'll talk about overhead in a little while. So what exactly happens here is, when it's creating the input split, it keeps on reading record and putting it into split as per certain logic. Okay, as per certain logic. The moment it realizes that if 5 has ended, it will not it will not keep on it will not stop across the boundary. The other input, so imagine this, there is this block, first block, second block, third block. These are three blocks existing on three different machines. On first machine it will finish reading, but it will not close it yet. And on the second machine it will start reading and will send some of this data to the previous input split. So each input split will not be of 128 MB. It can be smaller or it can be bigger. All right. So it looks like it's happening in sequence, but it doesn't happen in sequence. The way it happens is, your input splitters are all being run parallelly. And if the input splitter that is running on a node, if it has not noticed the beginning of the line yet, it will keep sending the data to the previous input split. Okay, the previous input split will accept the data, and then whenever it finishes its work, it combines all of this. Okay, so it doesn't have to be sequential. All right, there are too many questions, so let me go one by one. So Nitika, you got your answer regarding, let me copy it, that is I think a better trick. All right, let me just copy your questions. So no, the input split will not be of 128 MB. It may be closer to that, okay, but it will not be strictly 128 MB. All right. Now Vikas's question is, HDFS is also logical partition on local file system. That's correct. HDFS is nothing but each block will be stored on the local native file system. Okay, just like a file. If you go into the HDFS folder on Hadoop 1 or Hadoop 2, Hadoop 3, you will notice the blocks are basically a file. All right. Now Tarak's question is, does it happen sequentially? It doesn't have to be, but in certain cases it might. So the way it happens, reading of input split starts parallelly on all nodes, and each input splits decide, the logic inside this input split decide whether to keep the data with itself or send it to the previous input split. Okay, whether to accept the data or keep rejecting the data. When you say, when the one input split says I'm rejecting this data, the data goes to the previous input split. All right, that is how it happens. And that data which is rejected by second input splitter will be read by the first input splitter when it reaches that boundary, when it reaches that position. All right. So Tarak, I was able to answer your question. Okay, I could have actually shown you an example. I'll show you an example, no worries. Now Harsal's question is, how one input split knows the succeeding split. They don't have to be. Okay, each input split's logic is that, do you want to accept the current byte or you want to skip it? If you skip it, these bytes will be counted in the previous one. If you don't skip it, you consume it, then these bytes will be counted in the current one. Okay. So again, Tarek's question is, so in this case, record 6 sends to record 5. Not record 6, we will not say. The input splitter, this one which is running on the second block, will send this piece of code. We call it input split reader. Okay. The reader will send this piece of data to the previous one. All right. And so Nitika, do you still need a repetition? Is it clear now? Yes, it will become greater than 128 MB. That's correct. That's what I was saying. The input display does not have to be equal to 128 MB. Okay, and that's what the argument here is. The input is split. You can create very huge input split such that there is a single input split in case of say you are doing an unzip of file, or you are dealing with an image, and what you want is that you want to run the whole logic on the full file. In those cases, your all input splitters will keep on skipping the data. Only the first input splitter, the one who started with 0th byte, will read all of the data. Okay, it can be greater, it can be less. Okay, so there could be two scenarios. First, a really huge input split, or very small input split as compared to block size. Okay, if we have say a small input split, say 1 MB each, then there'll be too much of headache, meaning there'll be too much of data transfers from here and there, right? Because whenever we are creating an input split, there is a data transfer happening from one block to another, and therefore having the most appropriate size for an input split is as close to the block size as possible. All right. Yeah. So Vikas's question is, so the way it happens is the sixth one. So block one, block two, and block three. Okay, there are three blocks here. On the block two and block one and block three, all these three blocks, everywhere the input reader will be run. Everywhere there will be three instances of input reader running on three different nodes. Okay, and the input reader on the second node can either start accepting the data, or can keep on skipping the data. Okay, the moment it starts accepting the data, that data becomes part of it. All right, but therefore this boundary always goes to the left hand side. So half of the part of the 5 went to the left, rather than 5 becoming the becoming the member of the second input split. 5 became the member of the first input split. Similarly, 9 became the member of the second input split rather than the third input split. Okay, this the upper side represents the input splits boundaries, and this bottom side represents the block boundaries. Perfect. So there is nothing wrong in input split becoming bigger than 128 MB. There is no rigidity on input split size. It's up to you, up to your logic. It can become very small, it can become very big. Okay, but your intention should be as close to the block size as possible, not too much of data transfer. Vinay, are you with me? Yes. Block size is fixed. Definitely block size is fixed. We are not changing the block boundary. Okay, and block size will remain as is. These are read only operation. Okay, now imagine that one code wants to break the file by paragraph, other code wants to read line by line. Both these map reduce code can actually run in parallel. Okay, while block size will remain fixed. This is all in memory operation. You can imagine that input split is a memory representation of the blocks. Okay, Nitika? So blocks are physically stored on the disk. Each block, as I showed you in the one-on-one, each block has got a file which where it is stored. Now, when we read that file, when input split reader reads that file, it creates a representation like line by line, or it can make a representation like paragraph by paragraph. In case it creates a representation line by line, your mapper will get input in the form of line by line. Each map will get one line at a time. In case the input splitter contains each record as a paragraph, then your code will get paragraph by paragraph. All right. So it's like what you want to do with this data is decided by first input split, the kind of input split you are planning, and second, the kind of okay, the kind of mapper logic and reducer logic you are planning. Okay, so the fifth line, this is a fifth line which is being considered part of the first input split. Imagine that if part of the fifth line was given to first mapper and part of the fifth line went to the second mapper. Okay, it could have been, the boundary could have been on in the middle of a word. Okay, so the word count itself would become, that word will be counted twice, correct? Therefore, the input split is a logical representation which you can understand. You can say, I am dealing with this file as line by line, word by word, or paragraph by paragraph, or howsoever you want. That is the job of input splitting. Alright? Is everyone with me? Okay, so let's take a break of 5 minutes quickly and come back at 9:35 p.m. sharp. Hello, can you hear me? All right, let's start in 10 seconds. All right, so uh, is, who all did not get what does it mean by input split and the difference between input split and a block? Okay, so Sweta did not get it, Harshal did not get, and who else? Okay, okay. So it takes a bit of time. Okay, so I think it will be better if we just stay with our plain text example first. Now, when we talked about our plain text example, what did our code look like? Okay, our code, okay, so there were lines. So each line goes to our map function, right? And our map function gives out key values, right? This is something, the map function is giving out key and value, key and value, and key and value, correct? So a line is fed to your mapper, correct? Now, again, going back to the basic diagram, if I'm not sure if we have it here. Not this one. Yeah. So did you remember that this diagram? Here there was an input split. On top of input split, for each line, map function was called, meaning for each this input split was nothing but bunch of lines. Okay, and bunch of lines, when I say bunch of lines, these are complete line. It's not like half of the line went to one split and half of the line which went to the input split one. That is not something which is acceptable. Okay, so the full line, it always contains full bunch of lines. So each input split is a contains full lines, not the there is no there is no not something like half of the line went to one in split zero and half of the line went to split one, or half word went to the input split. It contains always the complete lines. Just like in case of a database, you have three sections of the table, like say split 0 contains 50 rows, split 1 contains 51 rows, and split 2 contains 49 rows. So in that manner, okay, so split 0, so here there are input splits, and remember that I told you that we'll talk about it later. So from blocks might be uh, as I told you, that blocks are basically a file ruthlessly cut at exactly 128th MB byte, right? That means when you're cutting that file, when you're cutting and storing in HDFS, remember that when you cut it, it wouldn't matter whether that segregation is at the word, or that splitting is happening on the in the middle of line, correct? Therefore, block 1 and block 2, or any block might contain the the boundary conditions, meaning half of the line has gone into block 1 and half of the line went to block 2. Now, when we are creating this input split, when when we are creating this input split on top of the block, okay? When we are creating this input split on top of the block, that means there has to be some sort of translation, okay? That means there has to be some sort of a translation, and that's what this diagram depicts. Here, the data was stored like this in blocks. Imagine that you have first line, second line, third line, fourth line, and fifth line. Some of the fifth line is part of the fifth line is in first block, and part of the fifth line is in second block. Correct? Now, when you are feeding these lines into to your logic, you want the full line. Correct? You want the full line. No. These split. So let's be very clear about the word when we are using. Split we are using in terms of input split, and block when we are using is in terms of HDFS block. Okay? HDFS and MapReduce are two different things. HDFS made it possible to store data by splitting the files. Alright? Now, either we could, load all these blocks once and run our logic on top of the full file, or we could do a little bit smarter stuff and run our logic or distributedly on individual node. Okay, now when we try to run our logic on individual node, we realize that the blocks do not contain the complete data. The boundaries are somewhere, the records are being sliced into two. Correct? And therefore it was important to create a input split, meaning complete the records by transferring the data. So the boundary get transferred over the network to create a input split. All right. So split is not 128 MB. Okay. Split is not 128 MB. You can think of it this way: two lines, one line really huge and other line really small. They don't have to be of equal size. Correct? All it has to ensure that these records are complete records. It should not be that half record went this side, half record that side. That of course means if we want to keep complete lines in the input split, we will have to violate the hard limit of like that of a HDFS block. Correct? So we have got on the block side, we have 1, 2, 3, 4, 5. 5 is being split into two. These are 5 lines. Imagine these are the 5 lines. Now we want full line. We don't want half line when we are dealing with MapReduce. What will I do in my code if I get only half line? My whole logic of word counting fails. If half of the word is in one file, half of the word is in another, the one word has become two words. And that too 50-50. Correct? Therefore it has to be, there has to be the border, the boundary data has to be either transferred to the left or the right. Generally the transfer happens towards the left, and the input split which is created on the node containing this block will contain all these 5 full records. Okay, and every logic can have their own definition of input split. Some might prefer each record as one paragraph. Some might prefer each record as one line. Some might prefer each record as one key value pair. Howsoever, we will talk about this. So, Nitika, it's not done by HDFS. HDFS only stored the data in blocks. HDFS doesn't care what your MapReduce will do in future. It's the duty of your MapReduce. It's your logic. You want to read line by line, you want to read full file at a single shot, or you want to read key value pairs, or are you dealing with an image where the coordinates are at a certain level. So it's up to your logic, okay, how you want to deal with it. HDFS cares only about bytes. Okay, HDFS doesn't care about what do these bytes mean. Do these bytes mean lines, or do these bytes are for the database file, or do these bytes belong to a CSV file? It doesn't care. Understanding that data is the duty of your MapReduce code. Yes, that's correct, Nitika. Great. So moving on. All right. I hope everybody understand now. Shweta and Vishal. All right. Nitika. Great. Great. All right. So so we talked about that input split is comprises of records. In our simple example of word count, each record meant a line. But in case you are dealing with a CSV file, the whole row, again, in case of CSV file, it's the same thing. But in case of a XML file, a single record might be different. Okay. A record is a logical entity, and you can take the clear analogy to database row. Each database row can be thought of as a record that is being fed to your mapper, one at a time. Okay. An input split is a bunch of or a collection of records. All right. Input, there is something called input format, that is what it creates records. We'll see this very quickly. Okay. So there are inbuilt input formats. Input formats create input splits. Input format or input readers create input splits. There are multiple kinds of format. The one which we have been using so far was text input format. Meaning, what does text input format does? So if you see here, in our driver, we were creating job dot set input format. Okay. So we have not done it. By default, this input format is text input format. Okay. So you can say here like this. Although this is fairly redundant. Okay. Yeah. So this way we can define that while running our MapReduce code, we can say that I want my blocks or my HDFS blocks to be interpreted by this input format. And hence, I will get, because of this input format, I will get each record as one line. In my mapper will get one line as a record at a time. Okay. So that is the work of text input format. So this is the default one. In case right now the record delimiter is what? Anybody? What is that by default record delimiter? New line. That's correct. Because line, when we say line, it's basically line 1, new line, line 2, new line, line 3, and so on. Correct? So default delimiter is new line. If you want some other delimiter, you can say slash n, slash something else. Okay. You can, if your data is like this, I'll show you. If your data looks like this, and each of these parts are a record. Each of these are records, meaning in your map function, you want this to be input. Okay. This to be another input, and this to be another separate line. So you can pass here semicolon. Okay. You can say in the conf, you can say job, or you can say text input format dot set input. There is a Okay, just a second. So yeah, job.set set properties. So in this itself, you can actually say set. All right, it's not there. Let me figure it out. How do we text input format? Generally, it is there in this itself. All right. Basically, you can actually define a config file, and we will show you somewhere. Conf.set. Yeah, you can simply say conf.set actually. That's good enough. You can simply say conf.set and you can say my, yeah, that's correct. So we can simply say like this, correct? In our example, you can simply say something like semicolon here. Okay, so this way every time map will be run, each map function call will happen first on this, second on this, and third on this. So there will be three function calls. Okay, so you, instead of a new line, you can define something else. Okay, when we say new line, whenever we are typing anything, this is the delimiter right now. You see this mark, this is the delimiter by default in case your text input format is there. All right, now in case if you strictly want if you want that each input split size should be exactly n number of lines, okay, you want that the each input split should have some sort of a fixed number of lines, then you can use n line input format. Okay, and using this property you can control how many records you want in one input split, meaning one instance of your mapper class will be created for 10,000 lines. Okay, each machine at a time will be running on 10,000 lines. All right, so in case these 10,000 lines are spread across 50 blocks, okay, so this data will be transferred from these 50 blocks to the first block. All right, if this file is really having big lines, really big lines, that means these 10,000 lines, whatever data is there, all of that data will get transferred to a single block, a single input split. Make sense to you? Because as we said, here we are enforcing that our each input split should contain n number of lines. Okay, now the other kind of input split format is fixed length input format. Okay, sometimes your input records are fixed length. If you have seen few of the proprietary formats, in case of say comma separated file, the records are separated by new line, and in each of the records the values are separated by comma. But in sometimes our records are fixed input format, fixed as in exactly uh, these many records represent something, and these many characters represent something else. So Okay, so in those cases you can use fixed length input format. Okay, while defining it here, you will say I want fixed length input format. It is picking up the wrong one. Fixed length input format. Yeah, so this is what it is. So remember that, keep this in mind. So this is where it exists, mapreduce dot this. Try to use the classes from mapreduce rather than mapred. Okay, mapred was something which was there in Hadoop 1.0, though we are using that here, but in future we will be avoiding it. Okay, so we'll try to keep only, that is why it's giving the warning that it has been obsoleted. So we'll be using the MapReduce one rather than MapRed one. Okay, because MapRed one were for Hadoop 1.0. All right. So all right. So syntax here you can see we can specify conf dot set, and this is the key and the value that is to Nitika. And by default, map processes one line at once. Correct. One record at once will be the best way to say it. Okay. By default, each map function processes one record at a time. The definition of record can vary from one input format to another input format. In case of text input format, it's one line at a time. In case of fixed length input format, it can be multiple line at a time. Okay, or it can be a single uh, you know single line but multiple times. So in case of fixed length input format, each record is defined as exact number of bytes, 5 bytes, 10 bytes, and so on. Okay, now by default, perfect. Now Vikas Mishra is going, if want to give 3 in one line go, then which one? Okay, yeah, you can say an input format, then that will give you 3. So yeah, so what you want to do is you want 3 in 1, therefore you will have to figure out a way to do it. Okay, figure out any other kind of input format. Okay, so uh, all right, Nitika's question, example of fixed length. Can somebody give me an example of fixed length? Have you read about something called fixed file format? Okay, so there is no input splitter in fixed file format, right? In fixed file format there is no splitter. It's just like, say, first name and last name has to be splitted out. So let's say we create fixed file format where each record is 15 characters. So we'll put 1, 2, 3, 4, 5, and so on. So is this 15? This is 15. So here we'll put another, and then we'll keep on going till 30. So this kind of format is fixed file. If we say that our record is 15, so it will start reading from here till here, because it's 15 characters, will become one record. This is one record. Record number 1 is this, and this is record number 2. This is record 2, and yeah. So the way you specify the uh, fixed file format is this way. Okay. So you can say something like this. You can say 15, and okay. So we told job that we are going to use input file format as fixed line input, and then this. Okay. Everybody okay? So from where we get all these functions, I'll give you the reference. Those are the good references, or you can actually go and search. The one which I've listed are given by default in case of Hadoop and on their homepage itself. Okay. Next is key value text input format. Okay. So these text input format which we read so far, the input was always value, and the key was always the byte count. Okay, instead of line number it was byte count. Okay, now in some cases you want to interpret your file as key value. Okay, in those cases you generally use key value text input format, and in case by default it the end of the line is either /n or /r, and the separator is configurable. By default it's equals. You can configure it to something else by setting this particular property. Okay, now this is something interesting. It's called sequence file input format. So whenever you have huge number of files, if you have huge number of small files, say each file is 10 KB, typically a GIF file, PNG file, all of them are generally 10 KB, 20 KB. Now imagine that there are 10,000 such files. Okay, even in a single so if you have 10,000 files, each of 10 KB, they will actually create 10,000 blocks, correct? And they might be spread across the network. Now in such cases it becomes very difficult to do the processing, specifically because there is too much of data transfer involved, or too much of a spread out of the processing is involved. Therefore, the standard way of dealing with such kind of problems is you combine these files together. Also, these files will consume lot of memory at the name node side, right? Because metadata is being consumed for each small file. Therefore, it is very much advisable that you combine these files like a zip folder, and then convert that zip file into sequence file input. Okay, there are tools to do that. Sequence file input format is a particular format called sequence file, and sequence file is a binary form of key value pair. So it is generally used when you have lot of data, lot of small files, and you want to process multiple single file at a time always. In those cases you combine them and prepare this sequence file, and then you keep on using your logic over this sequence file. All right, so sequence file is good when you have lot of small files and you want to handle it. Next is, imagine that imagine that you have to read a HDFS file directly inside your MapReduce code. Okay, you can also do that by using File System API. File System API is something provided by Hadoop for you. So in your say in your mapper class, here you can read the HDFS file directly. Okay, so here you will say something like read user slash student and something else. Okay, so every time this mapper gets called, every time you will be reading that file. Okay, next point is ggp splittable is something, this particular tool makes it possible to convert a ggp file into a format called ggp splittable. So a lot of time what will happen is when your data keeps on growing bigger and bigger, so instead of storing it without a compression, you start using a compression. Okay, the best compression possible is using Aljado, this one. Okay, yeah. So Nitika's question is, then if we are reading file directly from HDFS, so there is no need to give input folder input. Correct, but you have to specify at least some form of file so that Hadoop can, basically you can avoid giving the input file. But if you start reading directly, you know what will happen? Wherever the mapper is running, we will be fetching the data, we'll be bringing the data to the code rather than taking code to the data. Okay, this is a traditional way of doing things. Sometimes it's needed that we read file by ourselves. So this is basically the traditional way is read the data, bring it to the code, and then once you're done, you write it back and take it there. Okay. Also, you can have a look at the Aljado format that's quite much used when it comes to the storage of plain text onto HDFS. So you compress your data in the form of Aljado. Aljado compression makes it possible to 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 store the data onto Hadoop. Okay. So whenever you are doing a lot of text processing and you know that your data getting is spread across the network, it is it is better that you use Aljado. So each block will be a compressed format, and when you are trying to read the block, Hadoop will itself you know decompress that each block and then create the input splits. Okay, so have a look at the Aljado also. It's a very important to know, and ggp splittable is also very important. This particular tool makes it possible to convert a ggp file into Aljado. Okay, Aljado is a format, just like gzad, which is gunzip, normal zip, or you have say a rar. Similar to these compression techniques, Aljado is another technique. The only quality of Aljado is it's splittable, okay, at a certain block size. Because if your file, in case of zip file, half of zip file is only available to you, you cannot unzip it unless you get the full file. That's not true in case of Aljado format. If you have three parts, part 1, part 2, part 3, you can unzip them separately. Okay. So that is why it makes sense for you to use Aljado format when there is a too much of plain text data. All right. So we have talked about multiple things today. Now we talked about how to use existing input splits. At some time you might have to create your own input split. Okay. There will be times when you will have to use your own input splits rather than using these existing ones. In those cases, you will have to write a lot of it is a little tricky to use an input split. So the way you define it is you define a public class input split, which basically gives you length and the locations, and then okay, it'll be a little too technical. I'll show you an example. Okay. So each input split is basically a combination of the length and the locations. Yeah. So these are the in abstract class. Why? Because we can extend it and customize it. So whenever you are writing your own input split, you will extend input split, provide the meaning of get length. You will have to implement the get length function and also get location function. So when we talk about text input split, they have internally implemented input split. Okay, so each input split knows its length and knows where to read it from. Second is it provides the input format. Input format is the entry point in the game because that's what we specified. We said set input format, my input format. So whenever you're creating, the first thing you need to create is your input format, which extends this input format and then implements get splits and create record reader. All right. So I'll show you a quick example. This project is also available in the projects. So here, this is my input split format. This is my input split format, which extends the text input format. Here, I'm not extending input format. I'm extending something that extends input format. Okay, and here I'm returning my own reference to my own record reader, and this record reader is basically extending the basic record reader and is doing all of the game. This is doing the all of the game. Okay, so it's figuring out when to skip and when to consume. Okay, it's figuring out when to skip and when to consume, and that's the full role of an input split. So those who are very inclined, they can go through this code and try to understand it, and we can also have the discussion separately if you want. Okay, this code is available in our example in the session number 4. All right, so the role of record reader is to figure out till what point we should skip the data, so that that skip data should be read by the previous node, not the current node. All right. All right, so before we move further, is everybody okay till now? Good, good. So you should try it out. You should try it out. Whatever we have discussed today, you should try it out one by one. Okay. So I've given you examples. Yeah. So here theory is very much required. Okay. You cannot avoid theory because that's what actually works. And the real implication is look at the piece of code and try to configure it, and you will get the hang of it, what's going around. All right. Now we will talk about what happens in case of a multiple reducer. On what basis do we split the data? All right. These are little advanced things. We are going to talk about two things called partitioner and combiner. Partitioner and combiner is not little advanced. Whatever we have discussed so far, like input split, is little advanced thing. Okay. Partitioner and combiner both can be done in any other language, like using streaming. Using streaming, you can specify the partitioner as well as the combiner. We will talk about this now. So if you remember this diagram, we had input split being operated upon by map and being converted into key value collections. And once key values are generated by map, those are sorted, and after sorting, those are carried to the central location. Or you can say those are carried to the reducer wherever, whether it's a central location or somewhere else. It's those key values are carried there, merged there, such that they still remain sorted. And once those are merged, then each key value, each collection of key and values is passed through your reduce function. Okay. And then whatever is the result of reducer goes to the HDFS. Now here you can have a look at this. If you have multiple reducers, so if you have n number of reducers on each node, n buckets will be created. Okay, each key will be dropped into either of the buckets. Here there are two buckets, but in but in other if there are three reducers, there will be three buckets. Okay, there are three reducers, there will be three buckets here. So a key is dropped into a bucket. It's not dropped randomly. It is done based on certain kind of a logic. By default, the logic called hash code or a number generation scheme. Based on that, it is put into the corresponding bucket. But if you want to customize that logic, you can customize that logic and decide by yourself whether a key should go into first reducer or key should go into second reducer. You can configure it here itself. All right. You can write the code. You can decide by yourself. Given a key, return a number saying send this key to this particular reducer. That is the role of partitioner. So we create a partitioner class which basically decides whether a particular key should go to the first reducer or the second reducer. All right. Now you notice this. If we do the word count and we define two reducers, if we define two reducers, what happens is it stores the data into two files. Correct. Now these two files, if you try to just append one by another, the data is not sorted. Individually the files are sorted, but if you try to just concatenate these two files together, the overall data will not be sorted. Are you with me? Now imagine that your mapper was giving apple 1, apricot 1, and then boy, bat as 1, basket 1. So these are the key value given out by your mapper, and you have two reducers. Okay, by default what will happen is might go to the first reducer while apricot might go to the second reducer. Okay, let me just write it properly. So this is the output of this is the output of mapper. This is the output of your mapper, and say you have two reducers, reducer 1 and reducer 2. Okay, so apple goes here into reducer 1, apricot goes into here, while bat might go here and basket might go here. So there are two reducers, and when these files go into HDFS, same thing will be there. Okay, so part 0 will contain these two, while part 1 will contain these two. All right, now if you see, if you want an output such that if you can just append one another and it results in a sorted file, that will not happen. Correct? You will have to sort it again if you want the whole input to be sorted, right? So in case you have such kind of requirement that these two files, if concatenated together, should always result in a sorted output. Correct? So you can control that. You can control by saying that all the all the words starting with A to H should go to 1, or A to I should go to first bucket, and all the words starting with J to Z should go into the second bucket. In those cases, the first file will contain all the words starting with A, B, C up to I, and the second file will contain all the words starting with J up to Z. So that kind of decision is done by your partitioner. Okay, so I would first talk about partitioner. I think, yeah, okay. So this is the decision taken by the partitioner. So the partitioner code looks like this. Given a key value, partitioner returns any number between 0 to total number of reducer tasks. You are given three things in partitioner: the key, the value, and the total number of reducers available as of now. And then you return from 0 till n minus 1. Okay, and another example here, I'm saying that in case the gender is male, send that particular key to the first reducer. In case otherwise, send that particular key to second reducer. Okay, similarly, you can have a look here. Okay, this is my partitioner. This partition is saying that, that let me comment out the first one. Okay, this partitioner is saying if the key is starting with less than k, send it to 0, and in case the key is starting with anything is k or more, send it to the first reducer. So this partitioning, this division, that which key goes to which bucket, is being done by your partition. So after sorting, before sorting, each key is passed through your function and then decided in which bucket it is going to sit. All right. I hope the partition is clear to all of you. No doubt. All right. So this is how you can control what goes in first bucket and what goes in second bucket. It is similar to line splitter. Okay, so line splitter converted your blocks into input split, and here whatever mapper gave you the result is put into one bucket or the another. All right, it basically returns a number from 0 to n minus 1, where n is total number of reducers. Bucket means number of reducer, ith reducer. Okay, 0 means first reducer, one means second reducer. All right. Vikas, are you okay? Okay. Vinay's question is, so you have to write partitioner based on number of reducers configured. That's correct. That is why it gives you the third argument called number of reducers available. Okay. So say your logic is something like get the key, divide by total number of reducer, meaning compute the remainder. Okay. It will uniformly distribute the characters. Okay. Just that if alphabet A is too high, that means one of the reducer is going to get overloaded. Okay. Okay, let me just go through more questions. Okay, so Vinay's question is very good. So yes, so thank you Vinay for that asking question. Let me repeat what I just said. So whenever you are defining reducer, the total number of whenever you're defining a partitioner, total number of reducers are available here. Okay, so you do not have to customize your code if you change number of reducers. All right, this information is available to you through this argument. Yes, by this we will get output according to our requirement. That is correct, Nitika. So here if you use this kind of reducer, you are saying that all the words starting with A up to J go into first file, meaning first reducer, and hence each reducer produces one file in the HDFS, and second one will contain all the reducers from K to this. But of course this approach is invalid when you have more than two reducers. Okay, because we are hard coding 0 and 1. If you have more than two reducers, the third reducer or the fourth reducer all will go empty. There'll be not a single key that will go to the third or fourth or fifth reducers. Why? Because we are only saying send this to either 0 or 1. All right. Uh, okay, because this one is a little different example. The previous example was another project, and the one which we are dealing with is different. Okay, we are dealing in the first project, not the second project. We are in the first project. It's a very valid doubt. Okay. Yes, Vinay, that's correct. The default partition is based on the simple hash code. All right. So every string is converted into a number by a certain scheme that is called hashing scheme, and based on that is being decided. Okay. Use of partitionary is fairly optional. Yeah. It's basically the way you want to distribute. If you want to force your own mechanism of distribution of data amongst reducers, then you use partitioners. Although by default, the default way of partitioning of Hadoop is fairly stable. All right. So also note that if you have too many reducers, the shuffling effort will be high. And if you have few reducers, the computation of each reducer will take time. Therefore, you should tune it to the slots as we discussed earlier during streaming. You should tune it sometimes. Okay. Now, let's talk about an interesting idea called combiner. You remember our character count example? In character count, we desperately wanted that summarization step should be there on each node because we do not want to transfer too much of data. When we were doing character counting, at the end of every counting of characters, we'll have 26 numbers. Okay, so we should be transferring only 26 numbers from one node to another instead of transferring the whole bunch of key value pairs. Correct? So a lot of time we want to summarize on each node that after the map here after the map we want to summarize, we want to combine various values for key, various values for key. We want to do it on each node as if we are running a reducer on each node. Okay, this basically will also reduce, not only reduce the network traffic, it will also reduce the headache of the reducer. Okay, so you generally define the combiner function such that, just let me make a note of it. Slide 51. Okay, so whenever you are running a combiner function, you want to basically summarize the data on each node, meaning after sorting, the keys and values will be there. Before transport, we want to do some operation on the values. Okay, and that's where the combiner functions come into play. So it basically, the whole definition of combiner function is exactly like your it's exactly like your reducer function. Okay, and it's exactly like a reducer function, but there is a twist to the story. Although the combiner function has the same signature as reducer, but but it is not applied in the same way. In reducer, all the values are presented to reducer function at a time. While in case of a combiner, only few values are presented at a time. For a key, only few values are presented. Okay? Imagine that your combiner function was to find out maximum of some value. Okay? you say you wanted to you have temperature, you have a date and temperature kind of thing, and all you want to compute is, your objective is, this is a huge data you have. For each date you have temperature. Okay, your objective is find maximum temperature of the date of each day. Okay, day as in uh, day of the month. Okay, so all you will do is, basically your map will give out date as the key. This is date is your key, and temperature as the value. Okay, and your reducer will be a max function which takes multiple array of values and returns the maximum one. Okay, that will be your reducer. Mapper will spit out the key and the value. Perfect. Now you thought that you will basically reduce the headache of the reducer by transferring some of the computation to each node. Also note that same date might exist on another node, meaning same key might exist on another node. Therefore, reducer cannot be completely removed by combiner. Okay, combiner is exactly like reducer, but it will only have the access to the values of a key that are present on a single node. Okay, if the same key is also present on another node, combiner will not be applied on that. So fine, so combiner will also be, in this case, the max of values. Okay, the only difficulty with combiner is not applied on all of the values in a single shot. Combiner might get few values at a time, and combiner will get rest of the values again after some time. Therefore, your combiner logic should be such that that is something such that irrespective of how many values in what order are presented to you, it doesn't matter. For example, the maximum of 0, 20, 10 and 25 will always be same whether you compute maximum of 0 and 20 first and 10 and 25 again, and then you compute the max of those remaining two values, uh, or you take this value and this value once, and this value and this value once, and then resultant you again do the max. So you are applying max recursively. Okay, so when your output do not matter in these cases, then it is okay to apply combiner. Similar is the summation. Summation, no matter how you sum these values, first you sum first two values, or you first sum all the values together, the result is going to be same, no matter what. Is everyone with me? No matter how you sum up these values, the result is going to be same. Okay, if your aggregate function, if your reducer function is such that it for that function it doesn't matter in what order and how many values at a time are being presented to it, or how many times it's being applied, then it's okay to use that as a combiner function. But in case in case your function is like average. Okay, if your function is like average where it matters how many values are being presented at a time. For example, average of 0, 20, 10 and 25 is 11.25, and in case you average 0 and 20 once and then average 10 and 25 and then again compute the average recursively, then your value is 13.75. And if you change the order, then your value is 17.5, and hence you cannot use average as your combiner function. Are you with me when we talk about combiner function? So if you remember, reducer, the duty of a reducer is to combine the values for a key. Same is the duty of the combiner function. Just that, just that here the combiner will not be presented all the values as a single shot. It will be provided some values now, some values later, and so on. It will be applied recursively. Okay. So the average or the mean is not the correct function. Okay. So I don't know, Huda, that which one you want to repeat me, because I was not looking at the question. So which one did you not understand? So combiner function will be basically unlike your reducer function. In case of reducer functions, all of the values will be presented in a single shot, and you can keep on applying. You can have any kind of function as part of reducer, which can combine all these values together, or which can aggregate all these values together. But in case of a combiner function, not all values will not be presented in a single shot. Some values now, some values later, and whatever the result of these two, again your function will be applied again and again till it returns a single value. All right. Okay, so is everybody clear about combiner function? Now, if you are clear about combiner function, let me ask you this. There is this nice function. Let's say I define a function called root mean square value. Okay, it has got values, and all it does is it returns square root of, so square root of value 1 into value 1 plus value 2 into value 2 plus, and so on. So, and here we are not dividing with the total number of values. Okay, it's a different kind of a function, my fun, let's say. So this function, you can see, it's aggregating all these values together. V1 means values, the first value out of this array called values. So my question to you is this function a valid combiner? Anyone? Why so? Or let me write the actual code if I have to, you know. So, my product equals 0 for value in values. What do I want is my product plus equals value, and then I return my product. So same function, I have written it more programmatically. It's mostly a pseudocode. It's neither JavaScript nor Python. Somewhere it's like, all right. So nobody wants to change the opinion still? It's the same function. I've written it again as a code. All right, let's see. Let's take three values, okay? Let's take three values here. V1, V2, V3, or maybe, yeah, V3, okay? If you apply all of them, apply the function together, the result is square root of V1 into V1 plus V2 into V2 plus V3 into V3. That's correct? Now let's say we take V1 and V2 once, and the output is, let's call it Z. Z equals my function V1 and V2. Okay. Now if we apply my function again on Z and V3, the result will be, and Z will be, what will be there? Z? Z will be square root of V1 into V1 plus V2 into V2, correct? And here it will be Z into Z plus V3 into V3. Effectively, you will get, it will be square root of these two. Now square root of Z square, which is V1 into V1 plus V2 square plus V3 square. Now you see it's the same output. Did I confuse you? So, okay, I did confuse you, huh? All right. I'll have to stop asking negative questions. All right. So here we have V1, V2, and V3, and all we want is square root of V1 square plus V2 square plus V3 square, right? Now imagine that our combiner is this function called myfunc, and first this combiner was applied on V1 and V2. Okay, we got square root of V1 square plus V2 square. Now again, my function was applied on Z, which was the previous value, and V3. And this will be square root of Z square plus V3 square. And hence, square root of Z square is what? V1 square plus V2 square. This one plus V3 square. So effectively, we got the correct output. So no matter what, no matter how you apply my function, this my func, no matter how you apply on n number of values, the result is always going to be the same. So yes, it can be applied as a combiner. No matter how, but it can be applied as a combiner. So a quick question to all of you is sum a valid combiner? Great, yes. Now let me ask, okay, is the median a valid combiner? Great. Median cannot be a valid combiner. Reason being, median enforces that the data given to the median is sorted. And as I told, that combiner will not guarantee in what order the values are presented to you. Okay? Therefore, it's impossible to predict the result of the median whenever you run it. Alright? Why am I emphasizing on the combiner function? Because we'll be using this function, this kind of a definition, when we talk about Apache Spark. Alright, let's move on. So everybody is comfortable. If you have any doubts, you can ask now. What is that? Is difference a combiner? What do you mean by that? Combiner has to be a valid aggregation, right? So how is difference a combiner? I don't get it. Correct. Because the result of reducer and a combiner is a single value. And the values can be multiple, not only two. Correct? Alright. So the other concept here is the data locality optimization. Although we had been talking about it from the beginning, that Hadoop tries to execute the data, execute the code, execute your input split, and execute your mappers close to the data. Wherever the data is located, it will try to execute it either on the same node, or on the same rack, or on the same cluster. And the way this computation is done, so there are multiple ways of doing this computation, by the way. For example, this figuring out which two nodes are closer. Okay, so the green box represents the map, the task, and the blue box represents the data. Okay, the block. So either in the best case scenario, you would like to run your map task on the same machine. This is a rack. These are three racks in front of you. It's a single data center. Each rack contains multiple computers. And in the first case, this is our best case scenario. Our map task is being executed on the same machine as the one which contains the block. That would be the first priority. That will be the first priority of our Hadoop. Second priority would be our work gets executed on the same rack, maybe a different node. The third priority would be the data is on one rack and map is on another rack. And the fourth priority, the worst case scenario, would be to have data, one block in one data center and another, the map is in another data center. That is the worst case scenario. That scenario generally never arises. Reason being, first, there'll be at least 3 copies of this block. Okay, so if map could not find, if first block, the node containing the first copy of the block is busy, it will try to execute the map task on the second copy of the same block. If the second is also busy, it will try to execute on the third one. Okay, and then as you can see that there'll be 3 racks on which it can try further. Therefore, there are high chances that it doesn't have to go to another data center. Unless, of course, if you have 2 nodes only in your whole cluster, and one node is in one data center, other node is in another data center, that in those kind of scenarios, you can have the situation where map is on one data center and data is on another data center. So Vikas's question is, so such scenarios will be there if map and reduce are working on the same. Of course, yes. You mean to say so there could be other blocks also, right? Say if there is a machine, that machine must be having some hundreds of blocks, right? Therefore, that machine is a candidate for hundreds of map tasks possible. Correct? So machine might be busy because somebody else has executed the work, not only you. All right. So this is called data locality optimization. So it tries to optimize the data transfer. Now there are two standard strategies. There are two standard strategies to figure out the nearness of the data or nodes. The first strategy is keep pinging, and every node knows how far is the other node. Those kind of scenarios are there in the systems where a whisper protocol is being used, or you can say systems like MongoDB. In MongoDB or a Zookeeper, every node keeps pinging the other node. Okay, if you have n number of node, every minute there are n square. Each node is pinging the other, all other nodes, to figure out how far apart are the other nodes. So all nodes know the distance between each other based on how much time it took for a ping to return. Okay, let me repeat it. So there are two strategies. First one I'll talk about uh, another system such as MongoDB. In MongoDB also, the nodes try to figure out how far are they from each other. So they ping to each other and see how much time it is taking for pings to return. If the pings are returning faster, that means the other nodes are closer. So such kind of strategy is used in MongoDB and in Cassandra also, and in the Zookeeper also. Okay, but in case of Hadoop, we configure it. Although this strategy which we talked just now about MongoDB, this strategy is brilliant because we don't have to configure it. But this strategy is too much of a cost because you have to, it keeps on doing it every second, every 10 seconds, every minute, and it consumes the local area network uh, bandwidth. All right. So the main purpose of the data locality is optimization is so that we don't have to transfer the data. Okay, if our map task is executing on another node, then we have to take this block of data, transfer it somewhere else. So Hadoop will have to do it for you, transfer it to another node, and that would take a lot of time. And here we are talking about terabytes of data. A terabyte data takes around uh, 3 to 4 hours to read, even locally. Now think about how much time it will take if we are trying to read the data in a neighborhood. That is the purpose of data locality. Your code is always lighter. Your code will hardly be 10 KB or maybe 100 KB or maybe up to 1 MB. But but the data will be in terabytes. So it makes sense to take the mapper code to exactly the same node containing the blocks of data rather than trying to execute map task on some other node and carrying this data somewhere. So that is the of purpose of the data locality optimization. Giving you a real life example, take our word count itself, or any example. Even in the recommendation engine, we were churning 200 terabyte data, and we were doing it every 6 hours or so. Imagine that 200 terabytes data, it will take 600 hours just to read on our computer. Okay, if you have to transfer this data just to the neighbor node, just to nearby node, it will take a lot of time. All right. So all right, so that is the purpose of data locality, so that we don't have to transfer the data. Hadoop doesn't have to transfer the data. Rather than carrying the data to the node, carrying the data to the code, we carry the code to the data. And that is the whole premise of most of these big data optimizations. All right. So a quick question, can reducer take the benefit of data locality optimization? Anybody? How? Anyone? Right. So generally the reducer is on a separate node because the nodes which are running the MapReduce are anyway busy. So it's the reducer is generally on other node, and the data gets anyway transferred. Okay. Data will anyway get transferred across the boundaries, right? So generally, the reducer cannot take the data locality optimization into i- into a it cannot take the benefit of it in general. But if you look at it closely, if your mappers are running on rack 1, if rack 1 is running all the mappers, okay, the reduce it would make sense to have the reducer also run on the rack 1. Okay, so those kind of optimizations are being done in Hadoop every day. Okay, so the answer is not very clear. So in general, we do not see that reducer will take the benefit of the data locality optimization. Okay, so going back, imagine that there are three blocks: block 1, block 2, block 3. These three blocks are on the same node, same rack. A rack is an almirah where you keep these nodes. Okay, and each node is a computer. Okay, so this is one big almirah in which we have stacked one computers, and they are all connected through a hub here, and these hubs are connected to each other. Now imagine that mapper 1, mapper 2, mapper 3 are being executed on the same rack. Then it would make sense to run the reducer on the same rack. Okay. If you have reducer here and mappers running here, the data transfer will be across this network. That might be more intensive. So generally, uh, what Vinay is saying that generally whatever Vinay is saying is correct. That the the inputs of the inputs from each node are taken to the reducer, and therefore therefore it does not take locality. Okay, rack means an almirah. You can think of an almirah containing the computers, and each rack is itself a subnet or itself a what you call, all the computers in a rack are connected together by a hub, or okay. So yeah, these optimizations there, people are researching every day trying to come up with the newer things. All right. Yeah. So in general terms, when we talk about it, the data locality optimization is not something which applies to reducers. Okay, it applies to the mappers. But people are working on it, and in the latest versions, they have tried to figure out that reducer can actually run on the same nearby node containing the blocks. Okay, but that's too much of a stretch. There are high chances that the third copy of the block is off the rack. Third part is off the rack, meaning two blocks are on one rack, second block is on second rack, and in those cases the reducer cannot take the benefit of the data locality. You got my question, Tarak? Okay. So only in very specific cases, such as all the blocks are stored on the same rack or same almirah, then only those in those cases you can take the benefit of it. But in general, no. Next question to all of you is, if you have to store a file with a replication factor of 3, on which all node will you store this file? Okay. So if you have a file containing, say, let's imagine a file of 100 MB. Okay. So where all will you keep the copies of this file? You remember we talked about replication factor 3, and this file will only have one block. So where all will these three blocks go? Correct. So Vikas is correct. The two copies will go on the same rack and one will go to the third rack, some other rack. When we say other rack, we also call it off the rack. Okay. So the strategy is, the reason behind all of this is, so there are two reasons why it is done that way. I'll come back to this again. Why also this algorithm of which copy will go where, how copies are distributed in the network, that algorithm has been improving since Hadoop 1.0. Okay, as of now the general consensus is that two copies will be on one rack and third copy will be off the rack, meaning some other rack. Okay, because if one rack goes down, that's exactly correct, Tarak. If one rack goes down, it can be taken from another rack. All right. And why do we want to, as Shweta says, that why don't we keep it on three different nodes? That could have been even better. The reason is, imagine that we were running map on one node on a machine. Okay, one node on a rack we were trying to execute, and suddenly that thing goes down. So it makes sense to just start executing on the same rack but different node. The whole process will become faster. Also, while copying the data, first copy first copy will be on the nearest node. And if you are, say you are on Hadoop 1 and you are copying the data from Hadoop 1 to Hadoop 1, Hadoop 1 to HDFS, and since Hadoop 1 is also a data node, so first block of the data will be in Hadoop 1 and second block will be Hadoop 2, and third block will be third copy of the same block will be on the Hadoop 3. Okay, so f- the reason behind keeping two copies closer is so that the copy can be done very quickly. Okay, rather than waiting for the network to copy the data, the first copy happens very quickly and the second copy might take a little bit of time over the network. What is the data center here? It can be on different data center also. Yes, it can be on different data center also. All right, now let's talk about a few more questions. So yes, so first one will be on the local node and second one will be on the same rack. uh, this is the one. This is not correct. Second is on the same rack. Third will be on the different rack. All right. Now let's talk about how does it compute. Data center are physically different geographies. One might be New York, other might be India, third one might be in somewhere like South Africa. Okay, that's a data center. So distance between racks is comparatively small, while distance between data centers is huge. All right. Now, how does it work? So basically, you lay out your network topology when you are setting up your Hadoop. Okay. And the way you define it is, so in that case, if we are executing on HPL, no, the replication factor is with respect to the block. I'm answering Tarek's question. So is so it's not that if you have one block and it will have each data center will have three copies of it. If you have three data centers, there'll be nine copies of the same block. No, it'll be still three copies. Okay, so network topology is defined like a tree. You define your structure like a tree, and the distance between two nodes is summation of distance from their common parent. Okay, so node 1 and node 2 has common parent as rack 1. Okay, so you can look at it like this. There is this single data center containing two racks, rack 1 and rack 2. Each rack contains three nodes. Rack 1 contains node 1 to node 3, rack 2 contains node 4 to node 6. Alright? These two racks are connected to each other via switch. So the distance between node 1 and node 2 is how much? Distance between node 1 and the parent. Who is the parent of node 1 and node 2? Rack 1, right? Now summation of the two distances from their parent is 2. So distance between node 1 and node 2 is 2. Okay, and the way you represent this is in the form of file structure. Okay, so this one is switch 1 slash r1 slash n1, switch 1 r1 n2, switch 1 r1 n3, and so on, switch 1 rack 1, and so you can represent each node like a folder structure. And the distance you compute is by the way of summing up the distance from the parent, the common ancestor, the lowest common ancestor. So in case of rack awareness or data locality optimization, we understand the whole network as a tree, similar to what is our file path, a slash b slash c. And generally you write a script, topology script file, which basically converts an IP address into a folder structure. Okay, a folder structure, and based on this folder structure, Hadoop computes the distance between nodes. By default, it basically converts an IP address into this kind of a folder structure. Okay, and this folder structure will form the tree structure, and hence computing the distance in a tree structure is far more simpler. The distance is simply sum of the distances from the common ancestor. Now you can see this. Anybody? So how much is the distance from node 1 to node 1? Anybody? How much is the distance between node 1 to node 1? Here we have two data centers, data center D1 and D2. Okay, D1 contains two racks R1 and R2, D2 contains R3 and R4, and so on. And these are the nodes. So the distance between node 1 and node 1, who is the parent of node 1? So this distance is 0. Perfect. Okay, let's write it down. So distance is 0. Now in this case, anyone? Node 1 and node 2. Correct. The distance is 2 because if you draw the structure like D1, R1, N1, so the parent of N1 and N2 is R1, and the distance from both of this is 2. N1 and N3, N1 and N3. N1 exists on one rack, N3 exists on another rack. This one, anyone? 4. Perfect. Perfect. And N1 and N4, these are existing in two different data centers. Great. All right, brilliant. So 0, 2 and perfect. All right, any doubts on this? Okay, how we have 4 and 6. So let me just show you this way. N1 and N3, N1 and N4. Okay, N1 and N4. So who is the common parent of N1 and N4? Nitika? N1 and N4? Switch 1, right? Correct, correct. Now, what's the distance from N1 to switch 1? And N4 to switch 1? And what's the summation of the two? So basically, if you have to go to N1 to N4, the closest is 1, 2, 3, and 4. All right? Similar way here also, if you have to go from this node to here, so the common ancestor is other some switch. Common ancestor is some switch, and there, if you draw this diagram, you will figure out like a tree. Okay, if you draw it like a tree, you will be able to figure it out. Okay, or we can draw it here itself. All right, I think you got it. All right, so we are through with it. So that completes our session number 4. All right, so any questions here? So Vinay's question is, output formatter will be covered later. Is it similar to input format? So I haven't used output formatter yet. I need to maybe look it up. Is there something called output formatter? Have I mentioned it? No, no, actually there is no such thing called output formatter. All right. Let me go through quickly what all will we did we cover in the fourth session. So in the beginning we discussed about those problems, and I think this problem which we talked about here also suffers from the same issue. You see? Yeah. All right, just give me a second. I think I did not cover this in whole. Yeah, in this also we faced the problem that line by line was not sufficient. Okay, here what we were doing is we broke down the input into key value pair such that the first word becomes key and the second word becomes value, and that way we will know the frequency of the words that follow a particular word, right? In order to autocomplete it. Okay, this way you can actually do terabytes of data, terabytes of computation easily. But the problem here is that we are doing line wise processing while we should be doing sentence wise processing. Correct? We should be doing sentence wise processing instead of line wise. So you will have to create the input splitter here. Instead of taking new line as the record splitter, you will take dot as the input splitter. The input separator, record separator will be your dot. If you specify that, then you will be able to get one sentence at a time. Okay. So here, if you see, because we were not, since one line will be given as the input here. Yeah, and so on. Correct. Now the complexity arises. Some sentences end with question mark, other sentences end with comma, and sometimes the dot is part of the bigger sentence under double quotes. Or if there is a number somewhere, then dot is also part of that. So all of that, if you if you have to consider all these cases, then you will have to really work hard to build another input splitter. Okay, there is not a really good one available right now. Okay, so that's one thing which we thought we'll talk about later. Okay, so has anybody attempted this problem so far? Correct. The problem with that approach is that for each word, say is or are, there will be a million words following that word. Meaning, for the key example is, if the key is or are or of, then the values will be millions. So this approach suffers from first one. Okay, one is it should be sentence wise, not line wise. Second is the computation of frequency will become really tough for the words which are very popular, very common, such as is, am, are, of, uh, the total number of values for the key like the will be really high, and therefore it will be very difficult to come up with something. So Tarek's question is, does the Google work on word by word or sentence to sentence? It works in both ways. Okay, the bigger the better. Yeah. No, so sample input file is not provided to you, and you will have to download the data maybe from here. Okay, or maybe you take the sample from this place. Okay, Internally, they might be using a MapReduce or some other mechanism because it requires the churning of enormous amount of data. The total text is really high for them. Okay, every day they get a million queries. That means a million kilobytes, and to churn a million kilobytes, and every day that's had been happening for quite some time. Good. So the next question is how to avoid common keys that can have huge values. Can we create key as a composite key of first word and second word, and then we pick up only the one which is most frequent. Put some threshold on it, and then filter it further. So try to think on those lines. You will get the answer. All right, Goyal, are you with me? Vikash is not here. I think he has left. Yeah. So think about it. First, you attempt this problem. Try to attempt this problem. No, I'm talking about Vikas Goel. So he has solved this problem of this is called a computing of an. There is a good word for it. It's just slipping off my mind. All right, n-gram, correct. So how do we solve a problem of n-gram correctly using MapReduce? Okay, think about it. This is a difficult problem to solve, and most of the people who talk about n-gram, they are basically solving it for very small data. Solving it for humongous data is in itself an art. Okay, all right. Yes. I reviewed that approach. That approach is great, just that it cannot go beyond if the data is growing beyond RAM size. If the data is beyond RAM size, that approach in R cannot go because most of the R functionality operates on a single computer's RAM. So that's a downside of using that. Okay, but the strategy could be actually inspired by the same one. All right, now let's talk about, yeah, think about this problem. So solve all these 4 5 problems. If you know Java, try to solve it in Java. If you know Python, try to solve all these 4 5 problems which we have given in Python, and create your own GitHub repository. All our students create the GitHub repository and share that URL with us. Okay. So GitHub repository is a great way to get noticed, and that will also teach you many things with respect to the real way of developing. Like you will get to know about Git, you'll get to know about code review, and so on. All right. So all these 4 5 problems try to solve using GitHub, on GitHub. So GitHub. So create your own project. This is your first step to start getting noticed, and it's a very good practice to actually use Git and have a public repository. So you will get the first result of first assignment by next Saturday. All right. You will get the result of first assignment by next Saturday. Is it audible? Okay. All right. That's pretty much for today. Tomorrow we will continue from pig. Okay. Tomorrow we will continue with pig. All right. So those who are more interested in analytics, they will like those sessions more as compared to the programming intensive ones. All right. Have a good day. If you have any questions, drop an email to our Hadoop at No Big Data. And here you will see the sample project along with with an example of combiner, partitioner, and custom input. Try to run it with combiner and without combiner and compare the results. Compare the statistics. What took more time, what took less time, with and without combiner. Try to run this project. That will be the first guide, and then you code all of the five assignments, including the tuples one, okay, in your favorite programming language, okay, and put it on GitHub. That is your assignment. And in case you want to read more about MapReduce, I recommend the Hadoop Definitive Guide. Although the fourth edition is out, if possible, follow the fourth edition. Okay. So for all the problems we have discussed, along with those first session's problem, second session's problem, try to create a separate GitHub project and put all everything you do as a proper code over there. Along with that, run these examples: combiner, partitioner, and custom input split. Okay, it's a full project. You can import it into Eclipse, and then you can basically run it. All right. Try to run with and without combiner and compare the output of the two. If you have any problem, immediately drop an email to hadoop at nobigdata.com with the screenshot and whatever is the information required. Perfect. All right, then. Have a great day and see you tomorrow. All right. Great. Great. Bye bye. Have a good day. Thank you very much.